Welcome to MyOnlineStatusin.
So you have told me the answer. Which of the following is not a valid SQL type?
Decimal, ma'am.
Yes, you know, you don't have any data type called as decimal. Which of the following is not a DDL command?
Yes. Update, ma'am.
Update. Update belongs to
DML, ma'am.
and together you're right. Update belongs to DML. Transaction. It's commit and rollback. So what is a commit and what do you mean by a rollback? When I've made a transaction, right? So normally after you have done working with your Word file, what do you do with that Word file? You save a file, right? You have to save a file. So similarly, when I've created a table, I've done some operations on the table, I've modified it, I've added value, I've deleted values, I've done, right? When you have to save the changes, when you have to save all the changes, then you will have to give commit, right? Then you will have to give commit. Commit is very similar to saving. And what do you commit is the process where the changes that you have made will be saved to your disk. And next is your rollback. What do you mean by rollback? And suppose if you are not satisfied with the file, what do? You do undo, right? You do undo. So rollback is again very similar to undo. It brings rollback brings my database to a state that was before the transaction, right? Rollback brings your data, or you can say restores your database to the previous state before the transaction happened. Before we are doing this transaction, what was the state of my database? It will be put there, right?
Drop.
Delete all the rows in a table. Truncate. Views are also called as views are called as virtual tables. They are not actual tables. Views are called as virtual tables. How many this question? How many primary key can I have in a table?
Only one.
You can have only one primary key in a table. There can be only one key in a table. Which data type can store unstructured data in a column?
D.
Raw.
It's raw.
Raw.
Raw is a data type that is used to store unstructured data type.
Union, ma'am.
Not a constraint. You're talking about not a constraint. It's only your union. Union is a set operation.
Compute, ma'am.
Compute, ma'am.
To combine records from one or more tables.
Join, ma'am.
Constraints mean not null. Not null is one of your constraints, right? Remember, this is a very popular constraint. Constraints are the conditions that you place on a database, right? And this one, which data manipulation command is used to join one or more tables?
Join.
Join. Join is a command.
In, ma'am.
Option D.
absence of data?
Option C, ma'am.
Check by using your is null. So look at the database here. You have a database and I have a query here. This is your database now. And you have a query. So select count from select borrower and bank manager from loan records. This is the table that is called as loan records. And then you use natural join. Natural join is very similar to your join. So there are two more tables here. So make a note of it. You have S and you have T. So only if you can make a note of this table, you will be able to give me an output. So take a screenshot of both these slides. So I'll go to the next slide. Right, I've given the contents of the temporary table that you have in yes and you have in T. Now your job is to join these two tables. Join these two tables and give me an output. See, I've given you the contents of table S and table T also. This is your query. Hope you have made a note of it. Then you will have to do join. Yeah, I don't have options. There are no options. So this is a table. And from this table, see, I've built two temporary tables. And you will have to give me the answer. There are no options. So anyway, I'll give you the answer for this. So this is your answer. So make a note of this and just go through it. Okay. So we'll move to the next question. So we have two tables here. Passenger table and reservation table. Your passenger table contains PID, name and age. Then reservation table, PID, class and something, PID. Right? So can we look at the query now? So you have made a note of it, then we'll go to the query. So this is your query. You have to select PID from the table reservation. You made a note of this. We'll go back to the table. So what is the answer? What PID will be displayed here? So I have an and here. So you'll have to check whether the passenger age is greater than 65. And also the passenger.PID should be equal to reservation ID, right? Both these IDs should be the same and age should be greater than 65 and your class should be AC. So how many AC class do I have here? I have only I have only 0, 1, 0, 1, 5 and 3. But in this table you don't have 5. You don't have 5. So you are left with 0, 1 and 3. Now again come back to the table. 0. Sachin. What is the age of Sachin? Is it greater than 65? No, it is not greater than 65. And now Rahul, it's greater than 65. And 3 Anil is greater than 65. So only your PIDs will be displayed. So it should be only 1 and 3. Right? So the answer will be 1, 3. The answer will be 1, 3. Right. And now read the following statements. Right, you have read it. So the answer is already given. So just make a note of your answer, right? Both your statements are false. Can you tell me why? Why both your statements are false here? A foreign key cannot be replaced, right? And also that you cannot have two primary keys in a table. So both your statements are false. And remember this is your next question. So whenever a question is given like this, the employee is your name of your table, and this table contains employee ID, employee name, and employee department. And when an attribute is underlined, this means that, right? This means that this is your primary key. So remember this. Whenever I have an underlying attribute, we are talking about a primary key. And now this is your query. So tell me, what is your query? I'll have the answer there. Wait. Now, simply guess what does the query says? So you have an and here, and this says that sales rep ID is equal to your email ID, employee ID, right? Sales rep ID, and this ID should be same. And also C rating should be good. What operator is this? Remember, we have seen this. We have seen this operator when you are talking about your operators. Right.
Not equal, ma'am.
Called to be your not equal. This is very similar to writing your exclamation and an equal to symbol. So this is your, and your C rating is also not equal to good. And remember here, this is something called as not exist. This is not exist. So now tell me, what is the query used for? So you have gone through the query. You have gone through the query. Can I go to the options? Can I move to the options?
Yes, ma'am.
I have the answer there, but that is not an issue. Just go through the options here. Why is option D? Names of all the employees with all their customers having a good rating. Why it is option D? You have clearly stated here that the rating is not equal to good. Rating is not equal to good here, but your answer says that name of all the employees with all the customers having a good rating. So why do I have good here? Yes, Santana Krishna, your answer is right. So what about the others? So if you can see here, I told you that not exist, right? This is because not exist. So when I have a negative outside, inside it becomes a positive, right? Inside it becomes positive, right? That's right. So the next question, anyway, the answer is there. The statement that is executed automatically by the system as a side effect of a modification of a database, you call it as a trigger. It is called as a trigger. And the next question. So title is your primary key now. Title is your primary key, contains the title and prices of different books. Assume that no two books have the same price. What does the following SQL query means? You made a note of your query. Shall we go back to your options? Again, the option is also given for you. just reason it out why it is the title of the 5 most expensive books. So now you know the answer. So tell me why. Right, since it is given as less than 5 here, right? Since it is given that less than, but TB are 2 different books, right? Of course, as you all know that it's mentioned in the query that 2 books, no 2 books have the same price. The next query. You want the options? You want the options? I'll show you the options also. I think the options will have the answer also. The average salary of male employees is more than the average salary in the company. So what does your query says? So you need to select the department name from employee where your sex is equal to male. So you need to select only the male. So you'll have to group by the department name having salary greater than the average. So this is your case here. So you need to select only the male member's salary, and that too having salary that is greater than average salary from employee, right? So you'll have to select the average salary of the male employees which are more than the average salary in the company. Right, and this question, I'll give you the options. Since we are running out of time, a little bit fast. I'm doing it a little bit faster. Okay. So if you want, I'll send this PPT in your group also. I'll send this file to you, so you can go through that also. You will expect these kinds of query, right? You will expect these kinds of queries here, right? So the answer is C. And again, we will have only 2 more questions to be completed. And all those questions have answers here. Right? So I'll be sending you the file now. I need to send it to everyone. First question is option C. So I've sent it to one person by mistake. I'll send it to everybody. Please wait. First question, the answer is option C. Right, you have all got the.
Yes, ma'am.
Right, you all got the PPTs. Just go through it. Right. Since we don't have time now, I'm sharing it with you. So please go. Right, so now again we'll be starting with your transaction. So can someone tell me what is a transaction is? The operation that you do in a database, you call it to be a transaction, right? The operations that you do in a transaction database, you call it to be it's a transaction. And generally, this transaction, you say they are related operations, right? They are related operations. You haven't got the PPT, just click there to open. You'll be able to open it. Open. So is it opening? No, you cannot view it. What about the others? What about the others? You are able to view it? Wait, nobody. See, some are able to view and some are not able to view it. So people who are able to view it, can you share it with the others? Right, so no ma'am. So most of you it's not opening. Then I will ask your support team to share it in the feeds. Right, if you are not able to view it, then that's not an issue. Right, for those who are not able to view it, I'll again ask your support team to put the message in your feeds. Is that fine? Okay, that should be fine. Okay, so no issues. If it's not opening, you can just leave it and you can I'll ask the support team to post it in your feeds. Okay. So now when you talk about transaction, we say a group of related entities, right? So yesterday's PPT also, they will be posting it. Okay. So, right. So we say that this is one transaction and this is also one transaction. So what do you mean by this, right? What happens is that, so now we have taken an example for a transaction. So suppose I say an employee of a bank transfer 800 from X account to Y account, right? So this is called as a transaction. Transferring an amount from one person to another person is called as a transaction. And when I tell it's a transaction, the transaction will again within itself it contains some small level, many lower level activities are being done, which is not most probably visible to you. So first is what I'll have to do is that I'll have to open the account, and after open the account, I'll have to update the old balance, and after updating the old balance, I need to check my new balance. So new balance will be old balance minus 800 because 800 has to be transferred to your Y. And then I say balance of X will be the new balance, and after you have done the transaction, I need to close the account. So after that, this is with your X account, and now Y receives 800. So first you need to open your Y account, and then you need to update your old balance, and after that you say your new balance is equal to old balance plus 800, and Y dot balance is equal to your new balance, and you close your account, right? So this is a single transaction, and for transferring an amount from from one account to another account, you will also have many things that is being going on beneath you, underneath it, right? But so basically, any transaction is made up of two operations. One is your read operation and other is your write operation, right? So what do you do in your read operation? You read a value from a database and you store it in the buffer, right, in the main memory, right? So now, why is that? I'll have to read a value from the database, then I store it in my, the buffer in the main memory. Right? So please remember, when you talk about the memory of a computer, you will have two things. One is your primary. I'm just giving you a rough overview. One is a primary memory, and the other you talk about is a secondary memory. And the size of your primary memory will be small, and your size of your secondary memory will be, it will be a huge size of memory. So now what do I have in my secondary storage device? Large volumes of data will be there in my secondary storage device, and this is the place where your database will also reside, right? And now what about your main memory? As I told you that the size of your main memory is very small, and also it is very fast. Your main memory is very fast. Whenever any operations that I do, whenever I want a program to be executed, any program that has to be executed. So when I say a program, it can be a C++ or it can be opening a Word file, or it can be opening a media player, or any kind of operation, or you do a transaction in your operation in a database, that has to be done only in your main memory. Nothing can be done in your secondary memory. Secondary memory is only your storage area, and you cannot execute a program. Nothing can be done there. And if you want to do anything with the data, it has to be brought into your main memory, right? So that is the reason why when I say in my read operation, right, I am bringing the data from the database and I'm storing it in the main memory. So main memory is the place where your actual operation takes place. And the second operation you have is your write operation. And this is used to write a value back to your database. Right? This is again used to write a value back to your database. And since your size of your main memory is small, once you complete the operation, you don't have that in your main memory. You will again send it back to your secondary storage device. So, right. So this is what happens here. So suppose we'll take the same example of your debit transaction. You say you read X and you say X is equal to X minus 500, and then you write the value of X. First, you read the account of X, and after that you say you reduce 500 from the value of X, and then you say write of X. Now suppose, imagine that after your step 2, after my step 2, if my transaction fails, what happens? Okay. Amount will be debited from the account, but it will not be credited to your Y also. Amount 500 will be debited from my account, but it will also not be debited to your 500. So this is a case of a failed transaction. Even though this happens to your case of your failed transaction, who will take responsible for the 500 rupees that you have lost, right? So this is one scenario, right? So the same way, so you need to have you'll have many kinds of scenario in the same way. So amount is debited from by you, and before it is being credited to your other party, your transaction fails, right? Your transaction fails, right? So now who is going to take responsibility for that? So to solve this problem, we'll have two operations, right? One is your commit, the other is your rollback. As I told you, commit is used to save the work that is done by you, and rollback, it is used to undo the work that you have done. And to ensure this, right, to ensure that every transaction maintains some integrity in the database before and after your transaction. You have your asset properties, and remember we have seen your asset properties in your first class, so we'll not be going into your details. So first, so tell me the names of the asset properties alone: atomicity, consistency, isolation, and durability, right? So these are the 4 properties of an asset property. And when you take a state of your process, so you will have an active state, partially committed, failed state, aborted state, and committed state. So what is a active state? When you have a process, when you have a transaction that is in execution, you say that the transaction is in active state, right? So it will be in the execution phase, and the data will not, no changes will be made to your database, right? And the next is your partially committed, right? Partially committed. Your results of your intermediate operation, will be saved to your database. And when you say committed, this is the final stage of a transaction. So transaction has taken place, it has completed successfully, and the changes have all been made to your database, and all your changes have been updated in your database. And you have other 2 states, one is called as failed, and other is called as aborted. Failed transaction due to some reason, or maybe a system failure, if your transaction has stopped in the middle, or if it could not continue for some reasons, then you say that your transaction is a failed process, right? It becomes a failed process, right? So nothing will be saved to your database. No result will be saved to your database. It's just that it becomes a failed process. And next is your aborted. Failed happens automatically. Failed happens automatically, whereas when you talk about your aborted processing, so when you talk about your aborted process, this is where you play a role, right? For some reason, if you want to abort a transaction, it has to be done manually. You are killing the transaction. You kill the transaction. And if you feel there is some kind of violation or something, you kill the transaction and you automatically end it, right? So these are the various stages of your transaction. And now we'll talk about, when we are talking about a transaction, I told that a transaction is again a set of logically related operation. So now you need to know, when I told you it's a set of operation, then it is more than one operation that is being done in a time. So you need to have something called as schedule. And how is a transaction occurs? What is the first step? What is the second step? What is the third step? And so on. So you follow a schedule. And there are 3 types of schedule: a serial schedule, non-serial schedule, and a serializable schedule. So when you have a transaction, and that happens if there are 2 transactions, and you wait till the first transaction to complete, and after that you proceed with your second transaction, and no 2 transactions run parallelly. This is called as a serial schedule. When I have 2 transactions, T1 and T2, first T1 completes its execution. After your transaction T1 completes its execution, you start with your T2. After T1 completes, you start with T2. And you can see, and in the meantime, T2 will still be waiting. You don't have any of your operations of T2 happening in between. This is called as your serializable schedule. And it can be in your vice versa also. Then if you can see in the next example, first T2 completes its operation. After T2 completes its operation, then you have T1, and after T1 completes its execution. T1 completes its execution here. So if you can see here, it can happen in both rows. Either T1 completes first or T2 completes first. But if you can see, no 2 operations, no 2 transactions are operating in parallel. So this is called to be a serial schedule. And next is, this is an example of a non-serial schedule. So first you'll have some operations of your T2, and after that you you will have some operations of T2, then you have T1, and then you will have T2, and so on. So here it's T1, T2, and T1. So this is called as a non-serial schedule. When you have interleaving transaction, when you say interleaving transaction, this means that when one transaction is being executed and the other transaction also executes in parallel, then this is called as your interleaving transaction. And your third is that you identify a non-serial schedule. You identify a non-serial schedule and make it to be a serial schedule. Always your serial schedule, even though it takes some time, it will not cause any. It won't cause a big damage to your database, right? So the next is, what is NoSQL? NoSQL stands for a not only SQL or non-SQL. So this is again, when you talk about SQL, SQL is a relational database, but NoSQL is a non-relational database. And SQL requires a fixed schema. Schema is a structure. So when you talk about SQL or your relational databases, they are made up of table. But this is not your case of your NoSQL, and I don't have any fixed schema. If anything and everything can be used, any data can be added to your database as it is, right? And this, almost all your big companies have started using your NoSQL. So when do you use your NoSQL? If there is no fixed schema is required, you go for NoSQL. And also that many real-time applications, when you go for some real-time applications, and for each and every minute you collect terabytes of data, right? The data is collected in terabytes, right? Suppose you take Google, right? For a single minute, or take for example an hour, how much of data it collects, right? Everyone will be using Google for searching something. So this data has to be saved somewhere. So when I go for an RTMS, I don't have the facility for saving it. So that is the reason I go for a NoSQL here, right? So with this, we complete your NoSQL and we come to your normalization. So before starting into your normalization, you need to know about few things, right? So this is the first is your functional dependency. So when I say this is again a relationship that exists between two attributes, right? So this is again, we say it's a relationship that exists between a primary key and a non-key attribute, right? So even though we say in functional dependency, it's a relationship, and this is again a relationship that exists between a primary key and a non-primary key. So we say X tends to Y, right? So we say that, so X is a determinant and Y is called as a dependent, or you can also say Y is dependent on X. And X is called to be your determinant and Y is called to be your dependent, right? So this is your functional dependency. So I'll show you one example. Employee ID is your primary key and your employee name. So we say employee name is functionally dependent on employee ID. So there are two types of functional dependency: tribal functional dependency and non-tribal functional dependency, right? So we say B is dependent on A is a tribal functional dependency. You say that B is a subset of A when all your values of B belongs to A. So in that case, when all your values of A belong, so when all your values of B is functional dependent on A, then you also say that A is dependent on A and B is dependent on B. A is dependent on A and B is dependent on B. Okay? So this is one thing. And the next is again non-tribal functional dependency. Right? So we say B is is functionally dependent on A, and this becomes a non-trivial functional dependency when B is not a subset of A. So which means that when B is not a subset of A intersection B will be null. So this is called as your functional dependency. So this is like name is functionally dependent on ID and date of birth is functionally dependent on name. So these are two completely different things, right? So you just need to know this, right? So you just need to know what is functional dependency. You don't have to bother about your types. So all these things you will not be getting it in your so most probably whenever you say InfyTQ DBMS, it will always be, usually it stops with your second normal form. Usually it stops with your second normal form, and maximum you will again get only one question from your normalization. At the max, you will get only one question from your normalization, and almost like all your remaining 9 questions, you'll be getting it only in your SQL query. Right? You'll be getting all those things only from your SQL query. So these are again a set of formulas that you have. So when you take functional dependencies, from this you infer 6 inference rules. So that is what you will be checking here. So the first is a reflexive rule. Just remember the formulas alone. So we say in the reflexive rule, if y is a subset of A, then x determines y. If y is a subset of x, then x determines y, right? So you say A, comma, B, comma, C, comma, D, and y is equal to A, B, C. So you say y is a subset of x, right? And augmentation rule. So in the augmentation rule, you also call it to be a partial dependency, right? Augmentation rule is also called to be a partial dependency. So if say if x determines y, if x determines y, then x set determines y set. If x determines y, then x z determines y z, right? So for you have a relation and the table contains A, B, C, D. So if A determines B, then AC determines BC. Then AC determines DC. And next is your transitive rule. If x determines y and y determines x, then x determines z. Right? This you should all be studying in your mathematics. Whatever we have seen the inference rule, you would have studied this in your mathematics. And union rule. If x determines y and x determines z, then x determines y, z. And decomposition rule, right? So if you say x determines y, z, then x determines y and x determines z. And next is your pseudo-transitive rule. If x determines y and yz determines w, then you say x, z determines w. Right? X determines W, right? So just remember these rules alone. These are like formulas, right? So you have studied formulas like A plus B the whole square, and these are all very similar to your formula. And now remember, why do you go for a normalization, right? So you organize your database, right? What you organize in your database, and normalization is used for mainly to remove or to reduce redundancy in a data table, right? So what is your drawback of your redundancy? And when I have redundancies, you have some problems with insertions and your deletions operation, and this is called as your insertion and deletion anomalies. So whenever I have redundant data, I have these problems. So what is this redundant data? As I told you that when you have a college, your college will maintain your record, and again your department will maintain your record. So now, and again your class in charge will maintain your record. Your previous year class in charge will also have a copy of your record. So for a student, I've told you that your records are maintained in 4 places, or not maintained, but you will have a copy of your records. And suppose you have changed your address, and when you have changed your address, you will be informing that to your current class in charge, right? You will be informing that change only to your current class in charge. And do you go and inform your previous class in charge about your change in address? Would you do so? Will you do that? Yeah, change your address. And whom do you inform your change of your address? The change of your address will be informed by you only to your current class in charge. And your previous class in charge, the previous class in charge, you will not be informing. So your class in charge makes the changes in its own database. So in your other places, your data will not be changed. So you have multiple values, right? You have two address for you now, right? One will be the old address and the other will be the new address. Your new address will be updated in the table that is maintained by your class in charge, and whereas the other places it will not be maintained. So this is one problem that we have with your redundant data, and this is called to be your insertion anomalies, or you call it to be, on the whole it is called as insertion, deletion and update anomalies, right? So now we'll talk about your first normal form. So now I take a table and this is called as your employee table. And if you can see, employee ID, employee name, employee phone and employee state. And if you can take this employee ID 14, he has got two values for his phone number. He has given two values for his phone number. You say that this table is not in a first normal form. And for a table to be in a first normal form, you should have atomic values, which means that every table, every attribute should have only one value. So now you divide the table, right? So employee ID is being repeated 4 times. It's being repeated 2 times, and each and every column will have separate number. So this is called as your first normal form. So when you say that first normal form, every attribute should have atomic values, right? And remember, you'll be discussing about 2 attributes. One is a prime attribute and the other is a non-prime attribute. An attribute which is part of a candidate key is called as a prime attribute. And the next is which is not part of a candidate key, you call it to be a non-prime. And next is your second normal form. Right. When you say that your second normal form, the first thing, it should be in first normal form. Second normal form, for a relation to be in second normal form, it should always be in your first normal form. And in the second normal form, you say that all your non-key attributes, you want me to explain the first normal form again? See, first normal form. So look at your table here, only then you'll be able to understand. If you can look at the table here, I have got 2 values here. I've got 2 values for your phone numbers, right? I've got 2 values for your phone number here. And similarly, your employee ID 12 has also got 2 values for your phone number. And now what do I do after this? I split. So now 12 will be in 2 different rows. So atomic values means I'm meaning about a single value. So next is your second normal form. For a relation to be in second normal form, it should be in first normal form. And after that, you say in the second normal form, all your non-key attributes, they are all dependent on a primary key. Should be functionally dependent on a primary key. So we'll see this with an example. So you will have a table school, and this stores the data of teachers and the subjects they teach, right? And remember, when you have a teacher can teach more than one subject. So this is a teacher table, and this table has got teacher ID, subject and age of your teacher, right? And if you can take the teacher ID 25 here. So this teacher teaches chemistry, and also this teacher teaches biology. And you can see here, Again, this teacher takes max and this teacher also takes computer, right? So now to convert the table into a second normal form, we will have to decompose the table into two tables first, right? You will have to decompose the table into two tables. So how do I decompose them, right? So first it should be the teacher ID and then the age of the teacher. And when I decompose it in that way, I don't have repeated rows here, right? So teacher ID and the age of your teacher. Teacher ID and your age of your teacher. No repetitions are there here, right? So again, the next table. And when you come to the next table, again, I say that you say teacher and subject. So each and every time when you do that, you will also have to check whether your table is in the first normal form also. First check this table is in the first normal form. This table is in the first normal form because I don't have any multiple values, only atomic values are here. And next, I'm again checking this table is in my first normal form. Yes, this table is in my first normal form. So I'm removing, right, I'm removing the age of the teacher here and putting it in a separate table. So one table will be teacher ID and teacher age. The other table will be teacher ID and teacher subject. So in this way, all your non-key attributes are functionally dependent on your primary key. All your non-key attributes are functionally dependent on your primary key. And next is your third normal form. And for a relationship to be in 3NF, it has to be in 2NF, right? And does not contain transitive partial dependency. So you know that 2 normal form is fully functional dependent, right? So this is what you will be doing here, right? So you'll have to check for a functional dependency here. So you say that when X determines Y, X is a super key and Y is a prime attribute. When Y is a prime attribute, then Y is also a Y is also some kind of candidate key, right? Y is also some kind of candidate key. This is what we have studied there. So employee detail, this is your table. So it contains employee ID, employee name, and your zip code of your employee, state of your employee, and city of your employee. So first you need to identify which are the super keys and which are your candidate key. So how do you identify a super key? First you need to identify a candidate key. So candidate key again uniquely identified, but it can have more than one candidate key in a table. So I am taking employee ID to be one candidate key, and then employee ID is a super key, and all your other keys are dependent on your employee ID. So employee ID and employee name can be one pair, and employee ID, employee name, and employee zip can be one pair, and the next pair can be a employee ID, employee name, and employee zip, and employee state, and employee ID, employee name, employee zip, employee state, and employee city can be one pair. So you don't have to keep on bothering about your normalization. At the max, you'll be getting the first 3 normalization. It's always the first 2. The max is your first 3. So you'll have employee ID, employee name, and employee zip in one table, and next followed by the employee zip, employee state, and employee city. So you are decomposing your table. Remember, you are decomposing your table. So, and whenever it is 3NF, it should also be in 2NF also. So again, you check whether this table is functionally dependent on a primary key. So this is an employee ID. So everything is dependent on your employee ID. And in this table, you can take your zip to be a primary key. Since this belongs to a super key pair, you can also take this and you say that it all based on your employee zip, you will have your employee state and city. So based on your employee zip code, you'll be having your state and the city. So it satisfies 2NF also. And your last is your BCNF. And this is called as your boys code normal form. So this is an advanced version of your 3NF, right? So only if every functional dependency X determines Y, where X is the super key of the table and X is the super key of the table. So we'll have an example. We'll assume that there is a company where employee works in more than one department, and I have an employee and that employee works more than in one department. So 264 is employee ID. He works in designing as well as in testing, and similar way stores and developing, right? So now how do you derive your functional dependency? So you say employee ID determines your employee country, and employee department determines the department type and your department ID. Right? So employee country, you will have, employee ID, and then you will have the employee country, and employee department, department type, and your department number. Right? You are able to follow this. Right, so with this we'll complete your normalization also, and if you want, I'll send in your slides. You want me to send it now, or you want me to share it in your feeds today? So how do you want me to send in the slides now? Okay, if you're comfortable now, you can get it, or else I'll share it in the feeds also. Whatever possible method, I'll do that both. Right, I'll even send it in your feeds also. So I'll send it only to Pavitra. Please, I'll send it to everyone. That 21 pages PDF also. Where do I have the PDF? Which PDF you're talking about? That was a Word file. Okay. Wait, I'm not able to get the files now, so please wait. Once I get the file, then I'll be sending it to you. Please, someone tell. See, whatever it is, you'll be getting it in the feeds also, right? Whatever I'm sending now, you'll be getting it in the your feeds also by today. You'll be getting it in the feeds also by today. And you have anything else regarding DBMS? And please wait. You have by 3:30, you will have a short introduction to your TCS NQT. And after that, again, I want the students of Python to come back so that we'll discuss few more questions in Python. And for the DBMS students, right, I'm ending my session now for DBMS students, and all the very best. Do your exams well. Right? So please go through the materials that I'll be sharing it. I'll be sharing the materials with you, so you don't have to worry. So you can start your preparation. So all the very best. Do your exams well. Thank you.
Call on us for any support.